Up next, we have Dr. Heuschele. Close enough. It's making it good to be grain, enhancing rice production and ecosystem services with algae.
Right. I would like to thank everyone for attending today. I also would like to give a special shout out for my collaborators, Reba from the USDA and Ben Runkle from the University of Arkansas. And none of this work could have been done without our farmer collaborators at Isabel Farms. Okay. So recently, the USDA has put forward a very bold initiative, and that is to increase our food production by 40% while reducing our eco footprint by 50% in the next 30 years. One of the ways to do this is to use regenerative agriculture. Regenerative agriculture has many different definitions, but most of them focus on topsoil regeneration, increasing biodiversity above and below the ground, improving water use efficiency, enhancing ecosystem services, supporting biosequestration such as carbon sequestration, and increasing the resilience to climate change. Other definitions also add having farm economics to also be resilient in this system. Okay? There has been a lot of financial buy-in to regenerative agriculture, and there's been a lot of talk within politics. But companies are starting to put their money towards the farmers. For instance, General Mills has launched a pilot study to improve water quality using wheat and oats this year. Last year, Dannon has tried to do regenerative agriculture in dairy production in Europe. And even here in the Mid-South, Indigo Agriculture and Anheuser-Busch are partnering up to improve sustainability goals using rice. One of the many techniques and components of regenerative agriculture is cover crops. Now, we've heard a little bit about cover crops earlier today. Cover crops promote ecosystem services such as soil erosion, soil fertility. They work with water management, weed management, pest and disease. But not all cover crops are equal. It depends on what you're planting. Okay? But it does appear in our most recent study that came out in the last 6 months that cover crops, no matter what they are, increase soil biodiversity. And soil biodiversity is a measurement of soil health, a component of regenerative agriculture. Short-term effects, in this study, they looked at a 5-year pattern where they were able to increase the microbe population by 57%. When they looked only at the first year of planting a cover crop, that was an increase of 37%. Okay? So soil health is being improved. Within rice, we heard about rye earlier today. Soybean, any type of legume to be placed as a cover crop. And you can also dual crop using azolla, which is an aquatic fern. But today I would like to propose filamentous green algae as a possible cover crop on a rice-on-rice system. Our kind of project brainchild started with a farmer. And that farmer noticed, year after year, that some of his fields had filamentous green algae in them. They had this hair-like stuff, and it was fuzzy underneath the water. And in the spring, when he got ready to plant, the ground cracked so that he could put a tractor on top of it. But when he peeled it up, it still had soil moisture. And the thought was he saving water by having this algae layer there? He contacted us, and we then wrote an NRCS grant. And our goals of our study was, first, can we grow algae? Can we get it to grow in a consistent manner across a production size field? The second one was, are there any impacts agronomically to the rice if we impacts that occur when you're growing with this algae. The first one is the distribution of rice, distribution of algae. What we did is we did this in production level fields. Each of these is a 40-acre plot, and we compared it to 2 other non-algae treatment 40-acre plots. We collected native algae in the fall of 2017, and then I brought it back to Minnesota, and I cultivated it in a lab. So we were using native populations of algae. In the winter of 2018, we sprayed it. This little shapefile here, anything that's gray, there was no algae. Anything that was green is algae at certain concentrations. The darker, the more algae that was present. After we sprayed 32 different plots, 1 meter plots, then by April, we had complete cover of algae. We did not spray, then they grew rice on it. The next winter, we allowed the algae to grow again. We did not add any additional algae, and we ended up with 90% cover in the spring. So, agronomics. The agronomics, I'd like to comment about remind you of Dr. Massey's comment about statistical power. Here, what we found was, from those 4 fields and 2 years, there is no difference between our yield data. So there's no yield penalty, yet there's no yield bump when we have the algae growing. Okay? But we did notice in the spring of 2018, we got an email from our farmer. He goes, everything else has the rice, it's up, it's sprouting, it looks like we're going to have to reseed. We're like, oh no, it failed. 2 days later is this picture, and you can't really see it very well, but there are little, evenly spaced rice plants. He sent us another email and said, oops, my bad, I just wasn't patient enough. So there does appear to be a sprouting delay when you use algae on the field. Now, this represents water usage for last year. I want to explain this is very raw data, but it does illustrate a point. On our x-axis is date, on our y-axis is water depth. And at the high point, we can actually back calculate, looking at weather data, whether the farmer added, the water level is the farmer irrigated, or it was because of rain. And when you compare our control to our treatment fields, our control had 3 possible irrigation events, and our treatment field had 2 possible irrigation events. But there's not enough statistical power to say that we're saving water at all. This is a very complex issue. We are still kind of crunching the numbers to figure out what exactly is happening with water usage. But at this point in time, we're going to say there's probably no really saving of water. However, we do have statistical power to measure soil health. So to measure soil health, one of the methods is to do metagenomics. And what we did is we sampled our fields, 4 places in each field, and we ran metagenomics for both eukaryote and prokaryote. We measured diversity using the Shannon's Diversity Index. The higher the numbers here, the more diverse the samples are. And I realize you cannot see the colors very well, so I apologize. This is our treatment. This is our control. The pink and purple colors are the first measurements that we took over a 1.5 year period, and they're about equal when it comes to diversity, microbe diversity. The latter half, the green and the orange, are our treatment fields at the 2019, and we're seeing an increase in the microbiome. The diversity has increased. So a measure of soil health, we've increased it using the algae treatment. over the 4 different time points, or a year and a half that we measured, I want to draw your attention, not only were we growing or be able to get an increase in algae, or green algae, and golden algae, but we also had worms, so annelids. We had also snails, both in both systems. Okay. We measured prokaryotes as well. And with the prokaryotes, we were able to kind of look at not only how much was there, once again we have an increase in biodiversity with our algal fields, but what types of what types of bacteria were there? In particular, methane producers. We did not measure methane, but we were able to determine if there were any methane organisms that could do that. And the one I would like to draw your attention, there's 2 different classes. And the first one is this group here from Archaea bacteria. It is a very tiny black line, and it is only found in the algal treatment during the winter. Okay. So our concentration, compared to all of the other microbiota that we have there, for that particular methane producer, is 0.03%. Numbers kind of important, right? We also have a second class of methane producers, which is present in all of the algae, in all of the rice fields, okay? And for that, our treatment level, we had 0.5%, and in our control fields, which were managed in AWD, at 0.3. So why are these numbers important? Well, ideally, we would have wanted to compare whether these methane producers were in a flooded field. But we can look in the literature and compare our numbers to some previous studies. And this is a study that was done in 2012 under a continuously flooded system. And I want to draw your attention to the Archaebacteria, which is a representative of this rice system 1. They had, you really can't see this, I'm sorry. They had 4.6% of their population contained this type of bacteria for methane producer. And in this area, this was 16.6%, and we only had 0.5%. So in the rice fields with algae treatment, we found, yes, that we had methane producers, but they were a lot lower. So in summary, we found that there's potentially no yield penalty, but we had some delayed sprouting. We were unable to determine if there was any water savings, and some more detailed experimentation was needed. But we did see within the 1 year that we were able to measure an increase in biodiversity, which is a measurement of soil health. So can you use filamentous algae as a possible cover crop on a rice-on-rice system? Yes, you could. And I would like to also leave you with this image here. This is one of our fields in the winter with ducks. A part of regenerative agriculture is putting livestock on the fields on the off-season. Well, on a rice-on-rice system in Stuttgart, Arkansas, we do not put livestock on our rice fields. But we do have a lot of these. Are those our livestock? Are we already doing regenerative agriculture on our rice-on-rice fields? Any questions? I'm here.
We got time for questions. Any questions?
Did you do a soil analysis with the algae and the
Like what soil types we have?
No, in terms of what was the impact on soil nutrients?
No, we do not have that data.
You expect it, because it's incorporated, so there'd be a higher carbon.
Yeah,
But you didn't.
we did not measure that. This is a nice little pilot study. Really?
Just one of the details. How do you example this then assuming you scale this same column, right, with same varieties,
Mhm.
and what example is right here, 6
So what we did was we took soil samples off the first 5 centimeters of the soil during different types of the year, and then we sent. Pardon?
even half,
Oh, I'm sorry. We did in. Let me go back. We started our sampling in the right before planting in 2018. We sampled after planting in 2018. We sampled in winter of 2019, and then once again after harvest. Does that answer your question, Yulin? Yes.
Did you run any studies on decreasing weed pressure in the fields where you had algae, where you sometimes make your way through the algae, would that help?
So I don't know if everyone heard the question was if there was any weed pressure relieved on that. We did anecdotally see that when we had complete cover, that they were able to suppress the terrestrial weeds, but not the aquatic weeds. So timing of the drawdown was important.
So we tried to do something to help out at one time on the station. So what's the difference between success and failure?
Okay. What we saw is that allowing the algae to grow through the winter was important. And when we tried the experiment on the station, we only allowed the algae to grow for a month versus 2 to 3 months. And that was a very big, important concept.
You are growing your algae along with rice, right?
Yes, but the algae is growing throughout the whole year.
So it's a kind of a cover crop and a mixed crop too.
Yes.
So it's not only the cover crop.
Yeah.
That's what
There
we
is some aspect of dual cropping there, and there are studies that have been going on in Erie where they're using and capturing the biomass from the cyanobacteria as an additional crop for the farmer.
Any further questions?